Hello everyone, my name is Shyam Chauhan. In this lecture, we are going to cover exercise 3.1, question number 1 and question number 2. In question number 1, we have to convert the given statement into linear equation and then we have to solve the linear equation graphically. Question number 1. In class 10th, there are total 10 students that took part in mathematics quiz. If the number of girls is 4 more than the number of boys, then find the number of boys and girls that took part in the quiz. Let's assume total there are X boys and Y girls that took part in quiz. So total, that is total number of boys plus girls, equals to 10. That is the first equation. And second equation is the number of girls is 4 more than the number of boys. So number of girls, that is Y, is more by 4. So we have to increase 4 boys to make the linear equation. This is the second equation. Now to solve the equations graphically, we need at least 2 points for each equation, that is x plus y equals to 10 and x minus y plus 4 equals to 0. For first equation, if we put x equals to 0, we will get y equals to 10, and if we put y equals to 0, we will get x equals to 10. For second equation, if we put x equals to 0, we will get minus y equals to minus 4, that is y equals to 4, and if we put y equals to 0, we will get x equals to minus 4. Now to plot both the lines on the graph, the points for the first line is 0, 10 and 10, 0. Zero, 10 and 10, 0. The first line is passing through 0, 10 and 10, 0. Second line, the points are x is 0, then y is 4, and when x is minus 4, then y is 0. So the second line, when x is 0, y is 4, and when x is minus 4, then y is 0. This is the second line. This is the second line and this is the first line. Now we have intersecting point. That is, intersecting point is 3, 7. The intersecting point is 3, 7, that is x equals to 3 and y equals to 7. In examination, you will be given with the proper graph and you will get the exact points on the axis, that is x equals to 3 and y equals to 7. To verify this, we can put x equals to 3 and y equals to 7 in both the equation. So for first equation, if we put x equals to 3 and y equals to 7, 3 plus 7 equals to 10. And for second equation, if we put x equals to 3, that is 3 plus 4, that is equals to y equals to 7. 3 plus 4 equals to 7. If we verify using substitution method, we will get the same answer. Let us verify using the substitution method that we have covered in last lecture, that is x plus y equals to 10 and x plus 4 equals to y. If we subject x from the first equation, we will get x equals to 10 minus y. So let us put x in the second equation, that is 10 minus y plus 4 equals to y. We will get 10 plus 4, that is equals to 14, equals to y goes on the right hand side, that will become 2y. So y equals to 7. If we put y equals to 7 in the first equation, we will get x plus y equals to 10. If we put y equals to 7, we will get x equals to 3. So we have got the same solution using substitution method. This is just for the verification. Now question number 1, part 2. Part 2 is 5 pencils and 7 pens together cost 50 rupees, whereas 7 pencils and 5 pens together cost 46 rupees. And then we have to find the cost of one pencil and one pen. So let's assume cost of one pencil is x rupees and cost of one pen is y rupees. So we will get the equation. First equation is 5 pencils and 7 pens cost 50 rupees. Cost of one pencil is x rupees. So cost of 5 pencils is 5x rupees and cost of 7 pens equals to 7y, and total cost of 5 pencil and 7 pen is 50 rupees. This is the first equation. Second equation is 7x plus 5y equals to 46. That is 7 pencils and 5 pens together cost 46 rupees. Now to plot these equations graphically, we need at least 2 points, that is 5x plus 7y equals to 50. If we put x equals to 0, we will get 7y equals to 50, that is y equals to 50 divided by 7. If we put y equals to 0, we will get 50 divided by 5, that is equals to 10. For second line, that is 7x plus 5y equals to 46. If we put x equals to 0, we will get y equals to 46 divided by 5. And if we put y equals to 0, we will get x equals to 46 divided by 7. And now to plot the points. For the first line, points are x equals to 0, then y equals to 50 divided by 7. And when x equals to 10, y equals to 0. For second line, x equals to 0, then y equals to 46 divided by 5. And when x equals to 46 divided by 7, then y equals to 0. 50 divided by 7 is nearly equals to 7 point something, and 46 divided by 5 is 9 point something, and 46 divided by 7 is 6 point something. So first line is 0 comma 7 point something, first line is 0 comma 7 point something. When x is 0, y is 7 point something, nearly here, and when x equals to 10, y equals to 0. So the line passes from 7 point something and 10. Second line is when x is 0, y is 9 point something, and when x is 6 point something, then y is 0. So the line passes from x is 0 comma 46 by 5 and x is 6 point something and y is 0. So the line is passes from 6 and 9. This is line number 2. And if we see the intersecting points, we will get at 5 and 3. When you will plot on the graph, you will get the perfect points. Here we have got x equals to 3 and y equals to 5. If we verify the value, that is x equals to 3 and y equals to 5, that is 5x equals to 3 and y equals to 5, you will get 5 3s are 15 plus 7 into 5 is 35, that is equals to 50, that is right hand side. For second equation, if we put 7x is 3 and 5 into y is 5, you will get 5 5s are 25 plus 7 into 3 is 21, we will get 46, that is equals to right hand side. Now question number 2. In question number 2, we are given with the equation of two lines, that is L1 and L2, that is A1x plus B1y plus C1 equals to 0 and A2x plus B2y plus C2 equals to 0. We have to find whether these lines L1 and L2 represent intersecting point, parallel or coincident lines. So we can solve this question using the coefficients, that is, if we will start with comparing A1 upon A2 equals to B1 upon B2. If these both are equal, then we have to compare A1 upon A2 equals to B1 upon B2 not equals to C1 upon C2. In the second case, that is A1 upon A2 equals to B1 upon B2 equals to C1 upon C2. And the other case, that is if these two are not equal, that is a1 upon a2 not equals to b1 upon b2. Then for the second case we will conclude that these are intersecting lines. If these both are equal, then we will check for c1 upon c2. If this is the case, then it will be parallel line, and if for the last case it will be coincident line. Let us start with the first part. The equation of line is 5x minus 4y plus 8 equals to 0, and equation of second line is 7x plus 6y minus 9 equals to 0. A, B and C for the first line is 5 minus 4 and 8. For second line it is 7 minus 6 and 9. So if we check for a1 upon a2 equals to b1 upon b2 or not, we will get a1 as 5 by 7 equals to minus 4 divided by minus 6. This is equals to 2 divided by 3. We have 5 divided by 7 not equals to 2 divided by 3. Minus into minus is plus. These two are not equals. Hence we can write a1 upon a2 not equals to b1 upon b2. Hence the lines are intersecting lines. Now second part, the equation of lines are 9x plus 3y plus 12 equals to 0 and 18x plus 6y plus 24 equals to 0. A, B and C for the first line is 9, 3 and 12, and for the second line it is 18, 6 and 24. If we observe here, we have 9 2s are 18, 3 2s are 6 and 24 into 2 is 20, 12 into 2 is 24. We can conclude that these two are coincident lines. But to write the proof, we will start with a1 upon a2 equals to b1 upon b2, that is equals to 9 divided by 18 equals to 3 divided by 6. These two are equal, that is 3 2s are 6 and 9 2s are 18. We have 1 divided by 2 equals to 1 divided by 2. So in next step we will check for does this equals to c1 upon c2 or not. C1 is 12, C2 is 24, and these two are also 1 by 2, and from here we will write a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, and hence the lines are coincident lines. Part 3 is equation of lines are 6x minus 3y plus 10 equals to 0 and 2x minus y plus 9 equals to 0. A, B and C for the first line is 6 minus 3 and 10, and for the second line it is 2 minus 1 and 9. Let us start with a1 upon a2 equals to b1 upon b2, that is 6 upon 2 equals to minus 3 upon minus 1. If we see here, 2 3s are 6, minus into minus is plus, that is 3 equals to 3. Now we have to check for C1 upon C2 or not, that is 10 upon 9 or not. These two are not equals, so we can write A1 upon A2 equals to B1 upon B2, but this is not equals to C1 upon C2. Hence we can write this is the condition of parallel lines. In next lecture we will cover question number 3 and question number 4. Thank you.